Lecture 1. For the following items, you will listen to a lecture about face recognition technology. As you listen, mark the alternative that answers each question or completes each statement. Before you listen to the lecture, you will be given 60 seconds to look at the questions and the alternatives.
Today we're going to be looking at facial recognition and the different sorts of technology that go into facial recognition. Now, before we start, can any of you tell me where we can see facial recognition in action?
In a TV show like Las Vegas?
Yes, you're right. In this popular TV show, the security team pulls images of the individuals visiting the casino from its surveillance system and runs the image through a database to identify the person. In that way, all the card counters and blacklisted gamblers can be observed at the poker tables. It looks easy on TV, but in the real world, facial recognition is a tricky business. So let's start with the more traditional methods of facial recognition. Every face has peaks and valleys, and these can be translated into what is termed nodal points. In other words, nodal points are basically landmark points on the face. Each face has about 80 of these points, and they show the distance between the eyes, the length of the jaw, and the width of the nose. The measurements then can be used to create a numerical code, and this is what a face print is. The face print system is good because it can compare two-dimensional images such as photographs. However, the images to be compared have to be strictly managed. For example, the person has to stare straight at the camera, and there must be no variance in facial expression or lighting because any variance or change in these parameters reduces the effectiveness of the system. So, the new way of recognizing faces is using a 3D model. A 3D model has better accuracy, and it detects distinctive features in the face, such as the curves of the eyes, nose, and chin, the features that do not change over time. The distinctive features are measured at the sub-millimeter level, and a 3D system can recognize a person from a range of angles, so the person doesn't need to be directly facing the camera, as in 2D technology. Once again, similar to the face print, the 3D system gives each individual a unique code. But it's not just the measurements that can be used to recognize faces. There's also a new development called skin biometrics. This uses the uniqueness of skin texture to get its results. The process takes a picture of a patch of skin, and the system will then identify any pores, lines, moles, blemishes, and other features of skin texture. This method can be used to identify identical twins, which is something that cannot be done with the 3D technology. Also, unlike 3D, it can identify changes in expression, blinking, smiling, and so forth. In addition, it can compensate for changes in facial features, such as the growth of a beard or wearing glasses. So, now that we've covered the main types of facial recognition, we'll move on to its uses. Now, has any